Okay, and then I need to fix this. It's not my first... Kick's always like, it's my first stream.
Emotional, damn it.
It's not my first stream, Kick. This is my second stream. We had 2 views on Kick yesterday, actually. I'm quite proud of us. There we go. I'm gonna put us in the just chatting. I wonder if there's like any other information I could like put in here. It is quite funny how Kick literally just ripped off Twitch. Like, their whole interface and everything is literally a carbon copy of Twitch. It's quite funny. But okay, all right.
I think when they like released too, I think they like paid a bunch of people to like come over from Twitch.
To come over from Twitch. Yeah, they did. Yeah.
Yeah, they like sharked a bunch of Twitch streamers.
Dude, it's hilarious though. Like going through Kick here. Let's just like look at it real quick, just to like show you guys. It's kind of funny. Because like you go to this and literally even like the categories. See the just chatting here? This looks exactly the same as Twitch's. Same. It's literally the same thing. Like this is the big joke of like, yeah, don't steal my homework, right? You know, like don't copy my homework completely. Kick just like, they literally just copied their homework. Even the thing on the sidebar here, right? It's kind of there you go. Mine's like expanded out like that. It's just so funny. And then also, like, all of these streams, I say, most of them are either just people being IRL degenerates or just gambling on like Rainbet or something.
Let's go gambling!
Yeah.
That's all it is. I was like, this is a terrible platform. But
I only like it because it's green. I prefer green over purple.
I agree. The green is nice, yeah. So, I don't know. I'm just trying to maybe get into that space to go rescue some lost Peter Pan children or something, basically. All right, let's see. All right, let's. Breskles, you said you were gonna hurt me today with a question, right?
It's kind of scary.
It's kind of scary. Now, here's actually a really cool thing. Here's a cool.
People asked, and I gave them hyperbolic trig.
I do want to learn more about hyperbolic trig, and I guess we're going to learn about it today. But we'll see. I also implemented a fun little thing here. So when you submit questions to the queue, the second question you submit on the queue grows slower than the first one. So this is a way to kind of... I know people will come in and just like double tap, be like, oh, I'm going to just submit 2 questions, so I instantly have double the chances. But as we're seeing here, your second one grows a lot slower than your first one. Until your first one gets answered, and then your second one jumps up. So, I'm testing it out. We're coming up with all these fun little gaming mechanics for this to work. Okay, let's go choose a winner. See who we're gonna get.
Let's go gambling!
Oh wow, Equity, your second one got picked. That's hilarious. Your second one is the one that got picked. Okay, cool. All right, this. Wait, you literally just get Equity. What am I supposed to do with this dog? What? You want me to graph this or what? Was there something else on your submission maybe that told me what to do? It was just y equals. You want me to just rationalize it? Really? This doesn't seem like much of a question, Equity. One sec. Let me ping Equity. I'm curious. Yeah, I would assume just like rationalize it, but that's pretty easy to rationalize. Equity gives like harder questions usually.
It's a straight line too. It's not even like.
Yeah, I mean, this was their other question. This one to me looks like a little bit more. Is systems of polar? I think this. Oh, maybe this is. Yeah, maybe this is finding intersection points. I don't know what this is. All right, Equity's typing. Give me a second. Oh, convert from rectangular to polar. Oh, okay. Okay, we can do that. Yeah, we can totally do that. Okay. So we want to convert this from rectangular to polar. Oh, let's do it. Okay. So I want to convert. I don't know why is this up here, dude? What the hell? One sec. Let me refresh this. Messing up. Excuse me. Okay, there we go. That's better. I mean, it's a line, so it's gonna be theta equals something. Yeah, I agree. Yeah, exactly. Yeah. Yeah, so, yeah, equity, this is just a straight line, right? If you wanted to graph it. This is the same thing as y is equal to 1 over the square root of 3 times x. Right? Where this is now the slope, and yeah, it passes through 0. Yeah, Jeff has a good point. So you could do this. You could do this. You could just have 2 points here, right? So I know that 0, 0 is a point, and I know that what is it? 1 comma 1 square root of 3 is a point. So if you want to find the slope of this, which actually I don't even think I need the slope. Sorry, we don't even need that. We can just do this. We can build a right triangle. Right, something like this. And then this is the angle, theta. And then so, if your equation is theta equals, like, something, then that describes all the points along this line here. So, in this case, theta would be equal to, yeah, the arctangent of the opposite side. Well, the opposite side of this side is 1 over the square root of 3. And then over the adjacent. And the adjacent is just 1. Okay. So you just need an angle for that, which, I don't know. What's arctan of that? I feel like it's like 60 degrees or something. Let me get my calculator working. Okay. So do arctangent. It is 30 degrees, right? Yeah, that's what I thought it was. I was like, it's either 30 or 60. Yeah, there you go. 30 degrees! So sure, you could say 30 degrees. Or you could say pi over 6. Is what I would say. And the other way to kind of like think about this, right? If I know this is 1 over the square root of 3, this is the same thing as square root of 3 over 3, right? And then this is 1, but then this ends up becoming what, like something like really ugly. It's like the square root of 1 plus 3/9, right? Yeah. I'm trying to see like how you can make this look like one of the nice triangles, right?
It's square root of 4/3. 1 plus 3/9 is 1 plus 1/3, which is 4/3.
Good. Yeah. 1 squared plus square root of 3 over 3 squared is, yeah, that's equal to 1 plus 3/9. Wait, it's equal to 12/9, right?
No, that's 3 over 9 is 1 over 3.
Yeah, duh. Okay, but 12/9 is also correct.
I mean, yeah, but...
Okay, it's 4/3. Okay, so then this is 4/3, right? Oh, no, but it's that squared,
Square root.
right? Yeah, square root of that. Okay, is equal to that. So this is the square root of 4/3. So that's going to be 2 over the square root of 3 is this side. Right? And then here, this is where you should see things, right? Because the typical right triangle that we learn in pre-calc, I guess, right, is that if this is the 60 and this is the 30, then this is 1/2, this is square root of 3 over 2, and then this is 1. So if you divide everything by 2 over root 3, so you're multiplying by the root 3 over 2, in order to make this 1, let's do that. Let's just see. I multiply this by root 3 over 2, root 3 over 2, root 3 over 2, bingo bango, right? This is going to become square root of 3 squared, which is 3 over 6. So this becomes 1/2. This becomes root 3 over 2. And this becomes 1. And then you literally have this triangle. But, like, switched. And so, yeah, opposite that angle is the 30. What's up, Gladiator? Could you leave it as the cotangent... No, so, first of all, it's not cotangent of theta. It would be arc theta. Oh, I see. Sorry. You want to say... Why couldn't you leave it as... Wait, you're going to say cotangent of theta is equal to the square root of 3? And
I see. Taking the reciprocals.
Sure, I see. So instead of doing 1 over the square root of 3 for arctangent, you're doing cotangent, and then you're just leaving it like this. Because I think in polar form, you either need like r equals something or theta equals something. It's the same way in like rectangular form. You need like y equals or like x equals, right? Y can be a function of x. And that's when like it's a line or a curve or something. Or these can just be numbers, and then that describes things that are either horizontal or vertical lines. So if r is just equal to something, that ends up describing a circle, right? And if theta is just equal to something like a constant, that ends up describing a line through the origin. I think that's what your teacher wants. I mean, we could ask ChatGPT real quick. Let's see what Chat says. I always like asking. Let's see what Chat Daddy wants. Okay. Let me say, if I wanted to write this in polar form, what would it be? Let's see. ChatGPT? Yes, you always accomplish. Yeah. So here we go. Theta equals pi over 6. I agree. Yeah. That's the proper way to write it. Yeah. Cool. Yeah. You always want like r equals or theta equals if it's in polar form. Rectangular form, you can have y equals, x equals, whatever. Nice. Okay. Good question. I just spent 5 hours studying math. I'm never escaping it. Yeah, welcome, dude. It always comes back, dude. Nice. Thank you, Bobby Hill. Appreciate it. Okay, there we go. All right. Yeah, you're welcome, dude. Sorry, let me get all my chats working today. Chat. Where's my other chat? There you are. Today's my chemistry compartment exam. Oh, good luck on that, Silverian. And what's up, Daniel Hunter? Cool. Okay, let's save this question for equity. So we're gonna give it a nice little save there, and then we're gonna go put it into our Discord. So anytime we do one of the questions here on the stream, you can always see a record of it here. So if you go to, what's the channel? Sorry, homework help. No. If I could find homework help today. Excuse me. Oh, there it is. Okay. There's equities question, and then we'll drag it in. There's a solution for it, and then also there's a nice little timestamp that you can always go back and watch what we did. And you get a point. You get a bond coin for asking a question. If you ask questions on our stream and you participate, you can earn money towards gift cards and fun stuff. It's great. Go join. All right, let's go find the next question we're going to go work through. So interesting. I may need to fix this now because you see how equity's question has gone up to the top. So it's interesting. It's like a temporary nerf if they have 2 questions in it.
Yeah, I was wondering like what happened there. It just, unless I wasn't paying attention, I feel like it just like jumped up a lot.
Yeah, it's because and you let's think about this, Resticles, right? Whether this is fair or not. So let's say someone at the beginning of the stream submits 2 questions, right? And one grows really fast. One grows at the regular rate. One grows at a very slow rate, right? Because it's the second question per se. Once their first question is answered, their second question, I guess, should start growing back at the regular rate, or should it like get reparations for like what it was penalized?
It's a good question. I think maybe another way could be like each question gets half of the votes, right? So then.
Oh, so it splits them? Oh, so it splits the votes between them? It splits
it. So if you have like 2 questions in queue, it's kind of like a pick your poison. Either you could put 1 question in queue, or you could put 2.
Oh, I like that. That's a cool idea.
Either way, it's gonna grow at the same rate. So it just looks at like has
I
how
see.
many has this IP
What's
put
up, Zach?
in, and then like if they put it in 2 questions, they grow at the same rate, like combined, but each question individually grows at half the speed. And then once that question is
Interesting.
done,
No,
it
I
just
see.
starts
I
growing
see.
again at the
It's a
same
not
speed.
AI raid. What's up, Zach? We were just talking about AI-ish. Well, we're talking about like the queue system on vibe coding, of course, every day. Okay, I like. Okay, so if you have 2 questions, then your votes gained get split between the questions. Okay, I kind of like that. That's kind of a cool idea. I think, yeah, as it is now, it's kind of like it's a penalty during the choice system, so that you don't have double the chances. But I guess the problem here is that like the next try, your whatever nerfed question now becomes the top question anyways, because it's been in for the longest amount of time.
Yeah,
Yeah.
exactly.
Yeah. I think we would keep the upvotes the same. I think you could, because the upvote is based on the percentage of your base points, which is based on the time that's been in there. So I see. So I just need... we'll see. I mean, I'm just going to throw it at chat and tell it needs to code it. I understand why it coded it this way, the way it did, because it's the simplest math to, like, just have a nerf thing on it. But, yeah. Okay, cool. We'll see. Good day, $5. Shout out to Zach. Zach's another great streamer. This is cool. We're always improving the system, trying to like see what works. All right, so here, let's go choose another winner.
Let's go gambling.
It'll be interesting if equity gets picked again. No, it's gonna be Ace. Congrats, Ace. Ooh, calculate the molar solubility. Oh, fun. Doing chemistry today. Improved AI slop is still slop. We were talking yesterday about the trifecta of slop. What was it? Pizza Hut, KFC, and Taco Bell.
Oh yeah. The missing eigenvectors.
There you go.
of
There
our
you go.
world.
This
Yeah.
is the here. This is what Breasticles was referring to as like the reason why our country started going astray, is that these were our eigenvectors.
The entire world.
The entire world started going
world
astray.
went to
Sorry.
shit because Taco Bell, Pizza Hut, and KFC were our eigenvectors, and
These
now
were
that
our
we don't
eigenvectors.
have the 3 combined, like
Yeah.
KFC, Pizza Hut, Taco Bell. Now that doesn't exist anymore,
Yeah.
it's just sent our world into a spiral. I stand by that theory.
I stand by that. Yeah. So
It's
this
more
this
accurate than flatter.
this
I guarantee it.
this is when the world started going astray. Is when we got rid of
Exactly.
the triple slop in one location.
Exactly.
Okay. All right. Let's see. Taco F Hut. Yeah. Taco F Hut. Yeah. Okay. Taco Fried Hut. Or yeah. Kentucky
No, I
Pizza
think
Bell.
Kentucky
Kentucky
Taco Hut.
Kentucky Taco Hut. Yeah. Okay, that's good too. I like Kentucky Pizza Bell, but Kentucky Taco Hut also
That
sounds
one's solid too.
cool. Yeah. Okay. All right. Molar solubility. Ooh. Okay. Of AgCrO4 in a 0.55 molar solution of potassium chromate. Okay. Yeah, we have to do like this is solubility equilibrium. I think this is KSP. KSP, I think is what it is. KSP, K solubility, right? Okay, so you're gonna have Ag2CrO4, and that is going to hopefully. I think it's an equilibrium. I think it goes in between, but that's gonna form 2Ag plus, I guess. Wait. What is CrO4? I think is a 2 minus. Yeah, it is 2 minus. Okay, so yeah, that's 2Ag plus CrO4 minus. Right, and then this is solid, and then this is kind of like the aqueous part, I guess. Yeah, I believe this is what happens. And what this is called a common ion effect, because the potassium chromate is also going to contribute to chromate already being there. Yeah. So I think this is the solubility. But then you have a common ion from the potassium chromate, which is going to dissolve into 2K plus CrO4 2 minus. Sorry, this is 2 minus. Yeah. And because you have 0.055 molar of this, I think it contributes this amount. I think it's 0.055. I want to say. Okay. And then, yeah, finding molar solubility. All right. We need KSP first. Okay, so I need molar solubility of Ag2CrO4. Okay, molar solubility of silver chromate is this. Okay, yeah, I remember how this works. This is kind of cool. And that's a solubility product. Okay, Ag2CrO4 is this. And wait, do I need the solubility product? Is that what I need? KSP? S equals that. Okay, so KSP is equal to that. Okay. Bum, 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 bum. Okay. I'm starting to remember this. Okay, so this is KSP. And then, right, okay. So KSP is going to equal to the concentration of Ag plus, and that's going to be squared because this is, whatever the coefficient is in front of here becomes the power. And then this is going to be CrO4 2 minus to the first. And then because for every 1 mole of these, you end up getting 2 moles of these and 1 mole of these, I think... Oh, JC! JC, thank you, JC. What do we have here? Solubility product, I think. You can tell me if I'm doing this right. So, right, you have molar solubility of this. So Ag2CrO4, and then I'm saying that there's a common ion because you already have a solution of potassium chromate that's there. And so I know KSP... right, is equal to like this squared and then this, which I want to say this becomes like 2s and this becomes s. But how do you account for the common ion? Sorry. Let me think. Because then S is what I want to know. Yeah, okay. I think I remember. It's kind of like an ice table, right? Is it kind of like an ice table? Yeah, right? Because this is equilibrium. Okay. Yes, okay. I think I remember how this works. So you have... that AI thing won't work. Does this not work? I think it's ice, right? Okay. And then this starts with an amount of... I think S, right? And then the change here is going to be minus S. Right, okay. But you do know how much of this you have, right? Okay. So this I have 0, but then this I have 0.055, right? And then I think what happens... Oh, interesting. Oh, interesting. Well, I want to maybe see it with the S thing, right? If this... Oh, no ice... no ice, mi amigo. I hate that DHS fucked that whole thing. Like, I can't say ice without, like, thinking about, like, poor people getting deported. I think this is plus 2S. Okay, the S only works for pure substances. Okay, fine. Okay. Okay. All right. So I'll stop. All right. I see. I see. So, I can solve for the amount of AG plus, but how is that going to help me? Is that's just a concentration? Is that technically molar solubility? And it's this like divided by 2, I guess, right? I would like to use it this way. You know what I'm saying? I know like you have like some unknown amount. You're going to subtract some amount from it. So it's going to be like this minus this. And then this is going to be like plus S. This is going to be, oh, sorry, plus 2S. You just divided by 2. Okay, fine. Plus 2S. And then this is like 0.055 plus S. But I think what you're saying is that this is the final amount in it, right? Is the 0.055. Yeah, okay, exactly. Yeah, I don't know how much is there. Okay. So, I'm assuming that the amount of chromate from the potassium chromate is what sets the concentration of the chromate. I see, okay.
Oh my god.
I see.
Oh no.
I see. You're assuming that not very much of this actually dissolves. I see. Okay. Alright, so then fuck all this. Okay, just use this. Okay. Alright. Think of it as like the molar solubility as the limit of the concentration of that going to 0. Right. Molar solubility is like how much of this can I dissolve into constituent ions, right? Into the solution. Okay, and if this is set by this, then we're going to say that 6.5 times 10 to the minus 5. Okay, great. Thank you, JC. This is equal to, I'm going to call this like 2S, right? Squared, I think. Or maybe we're not going to do the 2S thing. Are we still just going to do S? Maybe just S. Oh, we are going to do. Okay, so 2S squared. And then this is going to be the 0.055. And then whatever I get for S, that will be the amount of this that like dissolved, I guess. Yeah, right? Okay. Okay, so let's pull out our calculator. So I'm going to do 6.5 e to the minus 5 divided by 0.055. And then we're going to divide that by 4. And then we're going to square root that. And so I'm going to get 0.017. So I'm going to get S is equal to 0.017. And I think that's in moles per liter, maybe? Is that the format they wanted in? Yeah, moles per liter. Okay, cool. Okay, very cool. I mean, and here, let me just send this at chat. I'm just curious to see what it says. Also, wait, why did they put 351 grams here? Why did they say that? Oh, 3 sig figs. Sorry, I can't read today. Let me throw it to chat real quick. Chat will get this. Yeah, that was for pure water. Yeah, let me try this. I didn't give it the question, actually. So for the AI thing here, I just asked what the molar solubility of Ag2CR4 was, because I knew I needed that. And then it started trying to do a question based on it. And I was like, wait. I don't actually need this. Like, because there's a common ion. But let's see here, right? Okay. Interesting. Wait. They put the plus S here, though. But I guess you assume S is small, since it already contains a lot of chromate. S will be very small. Cool. Wait, they got 2.2 times 10 to the minus 6. Oh, also, wait, whoa. They said KSP was 1 times 10 to the minus 12? Oh, Google got this so wrong. Hedgehogs per gallon?
Oh no.
No, dude, it's cheeseburgers per bald freedom eagles. Okay, wait. We got to agree on a KSP here. Oh, okay. Yeah, wait. Okay, I see. I read the wrong thing. Dude, I asked for... Okay, I should have asked for KSP, not molar solubility. I see what I did wrong. Okay, here, let me fix this. And actually, let me do this with the ice table, because the ice table is technically correct. I was correct with the ice table. Right? Okay, let's just see it. Okay, so ICE, right? This is an unknown amount, but I know I'm going to minus S. This is 0, and then this is 0.055 molar. This is going to add 2S. This is going to add a single S. So then my equilibrium amount is going to be 2S here, and then it's going to be 0.055 plus S here. And then whatever. This is question mark minus S, but I don't fucking know. Okay, so then KSP is equal to this. And this was the wrong KSP value. Okay, this is what I should have said. They also should have given this to you in the question, dude. Like, what? Like, be nice, guys. Okay. So that times 10 to the minus 12 is going to be equal to 2S. And then technically, this is 0.055 plus S. Okay. But I agree. This is an assumption we make when we also do titrations. Is I'm going to assume S is much smaller than 0.055. Yeah, no. But we're not going to solve the cubic. Right. Yeah, here's the and then this is what's called the 5% rule. Which is that when I get S, I need to make sure. So like when I get S, check that S over 0.055 is less than 5%. And then we're okay making this. This is the bastardry of chemistry.
Oh no.
Physics, we pull some pretty whack shit sometimes, but like chemistry's doing this as well. Where they're like, yo, yeah, just drop the term. It's okay, dude. 5%, who cares?
Oh no.
At least physics will solve a cubic. Yeah.
I think physics would solve the cubic.
Physics doesn't fear a cubic, yeah.
Yes.
Physics isn't afraid of
I fear no man.
a couple of terms.
And
by solve it, I mean probably just plug it in.
Probably just graph it or put it to Wolfram.
Yeah,
right.
One of the two, but it's close enough to solving it.
All right, we're gonna divide that by 4. Divide that by 0.055. Okay, so now S is very small, right? S is equal to 5. They wanted 3 sig figs, so we're gonna say 5.09 times 10 to the minus 12, and that's gonna be moles per liter. And then what you're supposed to do, right, is check that this divided by this is less than 5%. It most definitely is. I didn't do the square root yet. Sorry. Actually, I fucked up. Sorry. 2.26 times 10 to the minus 6. Had to solve a cubic by recursion in a chem Olympiad because you couldn't assume anything and it traumatized me. Oh no. That's terrible. Okay. All right, so then you check this. So then we should check. So what we would do is we would do 2.26 times 10 to the minus 6. And that's going to be over 5.5 times 10 to the minus 2. And, I mean, this is something times 10 to the minus 4. So it's already really small, but we can do it as well. So we do that, divided by 0.055, and then whatever, multiply by 100 to get percent. And so that's 0.004%. So you're good.
Yeah.
So that means the approximation was okay. Yeah. And I mean, here's kind of the justification, right? So a small number times something will mess it up. But a small number added to something won't really change it at all. Like 0.055 plus something that's really, really, really tiny is still 0.055. But 0.055 times something that's very tiny is not going to be 0.055 anymore. It's going to the multiplying like really affects it badly. So, yeah. Okay, there you go, Ace. I hope that makes sense to you. Good question. We love chemistry. Shout out to JC for helping me out there. JC is a great chemistry chap. Great chemistry chap. JC, I forget, what part of England do you live in? Or I assume you're British. Because I'm going to be in... You do need to stream again. We do need to get you there. But I was going to say we should go get a pint, because I'm going to be in London the 27th. No, the 20th. 21st. 22nd-ish. Yeah, I'll be there that weekend in London. If you want to come down to London, I might go up to Cambridge, I guess. How far is Liverpool? Let's go find. Of May. Yes. Yeah, of May. Liverpool map. There we go. I've never been to Liverpool, but let me see. Oh, yeah. Oh, way up there.
That's dope.
Okay, yeah. So I will be here in London. I will be in Cambridge. Getting to Liverpool, that might be a little bit of a hike. But I do need to go to Dublin the next weekend anyways. So maybe.
That's
I'll see
like,
what I can do.
That's like 2 blocks in Texas.
Oh no.
It is funny though. Have you seen the maps of where like all of this like fits in Texas? Have you seen that before?
Yeah, I remember seeing like a it was a meme, but it was at first like it looked legit. They just started like picking places and being like, yeah, this is
real? Is this real?
Texas.
Is this real?
I think
real,
so.
you think?
I'd seen one where they got to the point that they were like, yeah, Texas is bigger than Texas. Texas is bigger than all of America.
Oh no.
Texas is bigger than North America. Texas is bigger than the globe.
Oh, that's too good.
For like a solid 10 minutes it went on.
Oh man. How will you be getting around the UK? I won't have a car, so yeah, I'm just gonna take whatever the trains. I'm just gonna take some trains. They do have public transit in Europe, I know. I will take probably a Ryanair jet, whatever. I haven't booked that flight yet, but I have a Ryanair jet that I need to probably take from London to, I want to say probably Galway. Trains are so fucking expensive. Oh no. Okay, let's see. Yeah, London to Liverpool. Let's do it. Let's do in Google Maps. Let's do Liverpool. And let's get directions from London. Okay. So 2.5 hours, not terrible. But what's the cost? It doesn't have any cost. It just says get on the train. I don't trust that.
Oh no.
Okay. Really can't estimate cost for me? That's kind of silly. In Japan, dude, they'll tell you right away how much it costs. Let me see. Liverpool to London train cost. Okay, so that's a very big. So 15 pounds to 180.
Oh, hell no, man. What the fuck, man?
Okay. See, 15 to 30 euros, I'm okay with. 50 to 70 is still not terrible. I mean, I've spent more on an Uber just trying to like get downtown sometimes.
You done messed up, AA Ron!
Okay, on the day. Okay, so same day, peak is 100 euros. Okay, or 100 pounds. Sorry. So yeah, that would suck. Yeah, I wouldn't pay 100 pounds. I don't know. Maybe. Yeah. Maybe I'll come up to Liverpool or something. That would be fun. I've never actually been to any of that. I've been to really just like Cambridge. I've been to Ipswich. I've been to Norwich. Where else have I been? That's about it. Ely? Is Ely around here somewhere? I've been to Peterborough. Yeah, Peterborough Station. I remember somewhere. by a beach. I don't know. Okay, anyways. Just give me a heads up. I'll be in Europe for at least a week.
I don't believe that England has beaches. That's propaganda. I believe that England is like brick roads and rain
Factories.
and gloom.
Rain and gloom.
Yeah.
Yeah.
And,
No
like,
happiness.
Oh no.
smoke, yeah.
You done messed up, AA Ron.
Child labor.
Yeah, I refuse to believe of the possibility of like a
Beautiful
nice
England.
beach in England.
Although, so my friend did send me. There is a lot of interesting stuff going on in England right now. So they just banned cigarettes for anyone past the year 2009 will legally not allow.
What?
Well, yeah, they won't. Yeah,
hell?
yeah. Look it up. Look it up. Look it up. No, it's serious.
That's some bullshit.
Yeah, I know. The Texas inside you gets really mad, right?
The chain smoker inside of me gets really mad.
Yeah, there you go. Yeah, they've permanently banned cigs for future generations. This is pretty crazy. Anybody born after
Are vapes
2008?
still legal?
No. Anyone born after 2008
At
will
least they're
never be able to buy. That's crazy. I mean, I support it.
At
I mean,
least they
smoking
banned
is
the,
terrible. You shouldn't do it.
shitty ones.
But also, I don't think the government should like
My-
completely ban it. That's crazy.
Yeah, my like America, life, liberty, and the pursuit of happiness in me says if I want to kill myself with tobacco very
Yeah.
slowly and miserably, that's my right. Okay?
True. The argument is whether that's the strain that puts on the public health system, though. You know, but at the same point, maybe we should like restrict cheeseburgers from like obese people. No.
I guess, but
Yes, I don't know. The other one that's crazy is UK income revenue welfare. I remember seeing this. My other friend from England sent this too. Yes. Britain's bill on welfare now exceeds all the income tax that they make. So, like, oopsies. I wonder if that's true in the US. Do we spend more on like Medicare and No, of course not, right? Because we still have some massive black budget for our defense system somehow. So, I don't know. UK's going through some interesting stuff. You don't smoke or vape. Very good. Good job, JC. At least drinking makes you drunk, but smoking does nothing compared to that. Like, why would you breathe smoke? I mean, nicotine's addictive. That's what it is.
well, it's a really good stress reducer.
It is a good stress
time.
reliever. Yeah. Yeah. There are studies about
even
benefits.
Even like outside of the actual like whether nicotine in of itself is a stress reducer, for a lot of people that I know, just the fact that like the addiction forces them to take a second, stop what they're doing when they're stressed out, and take a very large deep breath and a very large exhale and worry purely on smoking. So it's like a
Chinese berry blast.
Oh no.
Yeah, exactly. It's like a addiction based take a deep breath and calm down type.
This is where I'm like, just go do yoga.
People.
Just go do yoga or something, please, guys.
I just, if I'm gonna die, I'm gonna look cool. Okay.
Yeah, I say that sometimes. I'm not here for a long time. I'm here for a good time. Whatever, But let's go to happier thoughts of doing math. Okay, here we go. Let's go. The queue's quite large actually, so let's go choose a winner. Who are we gonna have? Who's gonna be our next question?
Yeah, I was at like 5.
Let's
and
go
then
gambling.
just a bunch of people doing questions.
Let's see. Two equity got picked again. Breasticles. Wait, let me see what Breasticles has submitted. The arc tangent. Okay, propaganda. Dude.
Emotional, damn it.
Okay, here we're gonna do these. These shouldn't take too long. All right. Equity. What do I got? Do I have to just like find the intersection points? Is that what this is asking for? Equity.
It might be I think it might be polar to Cartesian. I feel like.
But why would they give me two of them? I think they want us to set it equal to each other. Yeah.
Oh yeah, you're right.
Right? Find the intersection points. Okay, cool. All right. Well, I think this one's quite easy, right? If I just need the r's to be the same and the thetas to be the same. So I can just like do this, right? Can I just say like 1 plus cosine theta equals 1 minus cosine theta? So then that goes away, and then I just get 0 is equal to 2 cosine theta. So I get cosine theta is equal to 0. So theta is equal to, what is that going to be? Pi over 2, right? Pi over 2. And also, I assume this is on the bounds of 0 to 2 pi, right? So I can say pi over 2 or 3 pi over 2. R equals 0 might be a special case. Correct. Let's go check it out. All right. So let's see. So when that happens, right? When this is 0 or this is 0, you just get r is equal to 1. So I think if we want to say in like r theta intersection, right? Also, do they want the intersection points in polar? Because in terms of r theta, I would say that's equal to 1 comma square root of pi over 2 or 1 comma like that. Okay. And then, yeah, I like this. Someone said, okay, but what if r was equal to 0? If r equals 0... Oh, okay. No, sorry. I mean, if r equals 0, then r equals 0, theta equals 0 is the same as r equals 0, theta equals anything. Lucky Cat says no gambling. I'm just getting it. Yes, I understand it's at the origin. So you want to say like 0 comma anything? How would you know the pole is a solution? Well, okay, wait. If r is equal to 0...
I don't think r is equal to 0.
Yeah, I don't think that works. Yeah, because 1 plus cosine theta can't equal this. You would have to what, right?
Yeah, you'd have to have a value where cosine of theta is
Negative 1?
positive and negative.
Exactly. Yeah. That's the only issue here, Jeff, right? If r is equal to 0, then this needs to be negative 1, and then this needs to be positive 1. But there's no theta that satisfies that at the same time, right? So I think that's what you do. I think so. If you know the pole is a solution, then technically 0 comma like anything should work, right? Right? And if this is 0, 1 plus cosine theta will be different than 1 minus cosine theta. Unless theta is this or this. Oh, okay, wait a minute. So wait, I think this is also a solution then. Wait. Yeah. Isn't this also correct then? Right? I think that would work, yeah? Because if this is 0, right? No. You can't have 0 equals 1.
No.
Yeah.
What am I saying, dude?
dumb.
Sorry, I'm
You'd
being really
have to-
dumb. Jesus Christ. Okay. No. Yes, the pole doesn't work. Both curves do touch the origin, but they don't touch the origin at the same theta. That's the issue. You could also graph this, right? If you wanted to do 1 plus cosine theta. Here, this would be r equals, right? Cool. And then if we did r is equal to 1 minus. Yeah, you have to have the same r and the same theta, correct? Yeah. There you go. So that's it, right? It's interesting. It won't actually mark this as like an intersection. I wish it would. Okay, so that's an intersection. That's an intersection. The issue is that when this intersects, this is at like theta equals 0, but then this one I think is at like theta equals what would that be? Theta equals pi. Yeah. The red one would be theta equals pi. The blue one would be theta equals 0. I think. Yes. No? No, opposite way around. But yeah. You can do it using a slider. Okay. How do I tell it to do a slider? Do I do this? I say X.
You could also show that the origin isn't a solution just by a substitution. If you say that at r equals 0.
Oh, here we go.
Cosine of theta equals 1, and then substitute that into your other equation and get.
Why can't I tell this thing to make? Why can't I say this thing to make a slider? I would like for it to be a slider. I don't know.
Oh, do a lowercase t.
Oh wait, there we go. Okay.
Oh, now it works. I guess now there's a slider.
Yeah, but what's that T defining? Oh, that T is defining this one now. I don't know. Okay, whatever. Fuck it. All right. Oh, it's not working. Okay. So yeah, no equity. 0, 0 is not a coordinate. I mean, you could just plug this in, right? If you're saying 0, 0 in terms of x and y, 0, 0 corresponds to r equals 0, right? But if this is 0 and this is 0, in order to get 0 for this top equation, this would need to be 1 minus 1, and this would need to be 1 plus 1. So these thetas would be different. What's up, Justin? What is the wording? That's a good point. Yeah, equity. You should maybe whenever you submit questions, try to. I know it may not be on this page, but try to like include what the instructions are specifically. But I think they just want the points of intersection. Wait, whoa, this is the answer? I don't agree with this. Wait, what?
No, I think they are correct in this. Because they say pole, I assume that they mean that there's a pole at 0, 0.
What
right,
does pole
so
mean?
if you do a singularity of discontinuity, if you substitute in right your cosine of theta, right? So if you said cosine of theta equals r minus 1, and then you do that substitution, if I'm not doing the math wrong in my head, you get like, I think it's r minus 1 or r plus 2 over r.
Okay, so that would be cosine of theta is r minus 1, and then this would be cosine of theta is equal to 1 minus r.
No, so in your second equation, right, keep the r there, but substitute, right, say r is equal to 1 minus parentheses cosine of r minus 1. Or not cosine of r minus 1, yeah, r minus 1 like you wrote.
R minus 1, right, okay, cool.
Yeah,
okay.
6%. Right,
so
and then so you get...
r is equal to 2 minus r. So
yeah, and then you can...
2r equals 2. So r equals 1.
Yeah, but if you divide by an r... Or, sorry, no. Right,
no.
Hold up, I'm
oh no.
there's a singularity or a pole, I mean, at 0, I think.
I mean, I agree that both of these things will hit 0, 0, but they hit at different values of theta. How's that an intersection? Do I just have to show that it hits 0, 0 at some point and like fuck it? That counts as intersection? I guess so. I guess yeah, how can 0, 0 be a solution when theta value is different? I don't know, man. That kind of bugs me. I'll let chat talk about that. I don't think so. if we ask where y equals 3x plus 2 and y equals 5x plus 6 intersect, we mean different x's and y's. Wait. No, their x's would be the same, no? What are you talking about? Different x's and y's. There's only one point where those are two lines. Okay, because theta becomes undefined in some sense when r equals 0. Okay. So you can't really describe theta once r equals 0. To me, point of intersection just means a point that lies on both curves. Okay. All right. I think I understand this, Equity. So, yeah. Because when you get like really close to the origin, theta doesn't really matter anymore, right? Because think of it this way, right? X equals r cosine theta, right? Y equals r sine theta. 0, 0 can happen if just r is equal to 0, and then I don't really care what's happening with theta. Yeah. I guess could I think about like trying to do this in, I don't know, this wouldn't look nice in Cartesian, would it? No. Otherwise two lines would never intersect. Sure. I see, okay. Chopped Liver says, I remember this, you just gave me flashbacks.
Oh no.
Chopped Liver, what's up, dude?
Oh no.
Get your ass on, boy.
The nostalgia is hard sometimes, dude. It's brutal, dude. Makes me cry. Oh no.
Oh, no.
What am I, chopped liver? I love that quote. Nice Ren Fair, thank you. It's good meeting you on Saturday as well, dude. Good meeting. Chopped liver. I actually like liver, honestly. Liver's pretty tasty. Okay. Okay, Equity. So yeah, so you have to check same r, same theta, and then you just have to check is r equals 0 like possible? Right? R equals 0 is possible here, right? Because you just need theta here to be equal to pi. And then it is possible here as well because theta would be equal to 0. Oh. I think the argument they're also saying is like, let's say for instance you had two lines. Okay. So let's say you had yeah, sure. Let's say like y is equal to 2x right here. And then you had another line that was I don't know. I'm trying to think another one that would be fun for this. Yeah, okay. Let's do this. Let's just say y equals negative x plus 6. Yeah, no. I think what he's saying is, okay, so here's two lines. And so if we wanted to parameterize this by, like, let's say, like, t, right? This could be parameterized as, let's just say, t, comma, 2t, right? This would be a parameterization. And then this could be parameterized as t, comma, what is this? Negative t plus 6. And I think these could intersect at different values of t. But they would intersect at the same values of x and y. So for instance, t like parameterizes like where you are along the line at some like certain point in time, some point in time. And then this would like, right, parameterize where you are in terms of another point in time. And where they intersect doesn't necessarily have to be the same time t. It just needs to be the same x and y. And so in polar coordinates, theta is kind of like the t, right? Like as we move in theta, the r changes, right? But there will be a theta for one of the curves that causes it to return to the origin that is different than the theta for the other curve that causes it to return to the origin. something like this.
That, and also, right, your theta can be literally any value at the origin, and it's still the origin.
Correct.
Is part of the point, right? Because if you're at 0, 0, no matter what angle you go around the circle, because you're at 0,
You're still at 0,
it's
0.
not gonna
Right.
change any sort of coordinates.
Yeah.
So we can't really like solve for it in the standard sense.
Yeah, and that has to do with this equity, right? By the parameterization right of x and y, if r is equal to 0, I don't care what theta is, I'm still going to be at 0, 0. Yeah. Okay. Yeah, the Tron video game. That's another way.
Oh, yeah.
Okay, so let's see here, right? So automatically right off the rip, yes, 0, 0 does work, right? Because both of these things will pass through r equals 0 at some point. I think that's the easiest one to check. Like, check if it's possible. Yeah, sure. This one's possible as well. Is this one possible? I think so, right? Yeah, 2 minus... Yeah, cool. 0, 0 works as well. Because I can find some value of cosine that'll make this, like, slightly less than 3. And we'll make it equal to 2. Yeah, okay, so that works as well. So, wait, the 0, 0 is always basically going to work. Unless you had something like this. If you had, like, r was equal to 5 plus cosine theta, then this wouldn't. Right? Then there's no way for this to get to 0.
This guy stinks.
Someone throw some gentle problems in the queue.
Oh no.
Yeah. For all y'all that are watching...
I'm wondering who's throwing in all the questions. There's
so we do have a queue here.
15 now.
This is the website, actualofficehours.com. While you're here submitting, like, nightmare level questions for me to do, please go check out our streaming schedule. So this has the calendar of all the different streams that happen with all our awesome friends. So Zach will be on tomorrow. Penn Center will be on. We're not streaming tomorrow, but we'll be on later. And then also you can join our Discord. And then, yeah, you can also go check out the queue. So look at all these fun questions that are getting submitted. Wow, this is the longest I've seen the queue. Why does it always happen when I have the short streams? Everyone dumps questions. It just always happens. Yeah, wait, what the fuck is this, dude?
Oh, dang it.
Someone's just having a time, dude, with some of these questions. I might have to hit it me first, yeah. Well, that's why it's there for you guys. If you watch the stream a lot, you can hit me first. Just outrage after another. Yes, I agree, equity. Yeah, as long as, yeah, if they both hit the pole, even if it's at different values of theta, then the pole is definitely a solution. Yeah, they are different shapes. A Galoy group in the cube? I don't even know what that is.
Oh no.
Okay, yeah.
I've heard of it, but that's like a modern algebra type of deal. So
yes, so these are two different shapes, actually. So you are right that this is traversing twice as fast in terms of theta. But that means the R is changing like twice as fast. So if you go to Desmos, here we'll look. I'll show you guys what I'm talking about. Yay, field extensions. We always get like some YouTube math warriors that find us. Okay, so if R is equal to sine of theta, that's that, right? And if R is equal to sine of 2 times theta, you get this. Actually, this is really similar to what was it?
Zach was doing?
Zach was doing. Yeah, he was doing this earlier, right?
Yeah.
So this is cool, right? You can say like 3 theta, right? 4 theta, 5 theta, 6 theta, 7 theta, 8. You can make like all these really, really pretty things. Because what's happening is think about how sine works. Sine oscillates between -1 and 1, right? So as your angle is like sunsetting, like as your angle is moving around, R is going back and forth between positive and -1, right? And so if the rate at which it's doing that, it's faster and faster, it's going to trace out like more petals. In the case of, right, that it only oscillates once, it only makes a circle like this, right? like 2 theta, you get this, 3 theta, 4 theta. And the reason why sometimes you get more and less is you start getting overlapping petals on each side. So I guess on odd numbers, yeah, on odd numbers you get overlapping amounts. Yeah, it's actually kind of cool that works. Okay. Nice, I was wrong again. Purdy lines. What's up, Broken PH? Okay, alright, so anyways, here, if you want these to set these equal to each other, right, we can say, I don't know, are you supposed to just graph these? Right, sine of theta is equal to sine of 2 theta. I feel like I need a double angle identity here. Is this sine theta cosine theta? Is it 2 sine theta cosine theta? I think so. Reviewing. Yeah, let me see. It is. Thanks, Justin. Okay. Okay, so here's the cool thing, right? So once you're here, you'll notice, right? I could divide both sides by sine theta. But then I gotta make sure, tricky. I gotta make sure I don't get rid of the solution where sine of theta is equal to 0. And that indeed, right? That happens at pi over 2. And also happens at sorry. That happens at 0 and it happens at pi. But 0 and pi, r is both equal to 0, so that's the pole solution we already had. Yeah, okay. So, yeah. So those two would go away. We're dividing by, okay? And then, yeah, exactly, Fem. You get that, like, cosine theta is equal to 1/2. And so that occurs at pi over 6 and 7 pi over 6? 7 pi over 6. No, pi over 3. Sorry. I was getting the cosine sines. Sorry, pi over 3 and 5 pi over 3. Yes, thank you. Okay, so those are the two solutions for theta. And then you just plug them in here for what r would be. Let's see if that makes sense. So sine of pi over 3 would be square root of 3 over 2. And then sine of 2 pi over 3 would also be positive square root of 3 over 2. Okay. So, yep, these are solutions. Pi over 3, square root of 3 over 2. And then this one, so now you get the negative thing. So you would get 5 pi over 3 negative square root of 3 over 2, right? Which, interestingly enough, I think this is the same as this. Or no, it's not. Wait. Pi over 3 is up there. Right. Interesting. Oh, actually, wait. These are copies of each other. No. Okay, never mind. This is it. These are the two solutions. I think so. Yeah. Okay. And then the pole. Was that correct, Equity? In terms of solutions, those ones? This, set them equal, right? You just get sine theta equals cosine theta. So that's just where tangent of theta, if you divide it over, tangent of theta is equal to 1. And so that's going to be at pi over 4 or 3 pi over 4. Yeah, 3 pi over 4. Which, Lurk, real life issue, not protesting the nature of these Q questions.
My name is Jeff.
Okay, stay okay, Jeff. If you plug that in, that's square root of 2 over 2. So that's going to be pi over 4, comma, negative 2 square root of 2. Oh, I swapped r and theta. Oh, I did. Sorry. Yeah, this was theta r. My bad.
Oh, brother,
Yeah,
this
theta
guy stinks.
Okay, you got the rest. Cool. All right, great. Good job, Equity. Fun questions. Made me think. You're welcome, dude. Nice. Okay. So we'll take that question. We'll put it into our Discord. So mark it as done. So yeah, if you guys ever want, if you're in the chat and you want to maybe, contribute, or you have some extra thoughts about the question, all the questions we do get put into our Discord here, and then I always like dump the screenshots for the students, and it also has a little timestamp so they can see when they did it. So please feel free. Go join our Discord. We have lots of fun activities we do. We might have a chess tournament on Friday. Depends what the game of the week is. That gets voted on Thursday.
Good job.
So we got a couple me firsts. Pineapple had it first. So Gladiator, you're going to be after Pineapple. So I normally would run the thing on the queue here, but we do have, if people watch the stream for long enough, they can buy perks, and one of the perks is to skip the line. I may start having to raise the price on that as things go on, but for now I will respect it. Okay, so first one was... Okay, Lucky Cat. Is this your question, Lucky? Pineapple, is this the one you want? What's up, Arya? Sorry, there we go. So you can see it. Okay. Determine the equation of the function with the following key features. Decreasing for x is greater than or equal to 2. Has a y-intercept at that. X vertical asymptote at that. X-intercept there. Domain of that. Range of that. And has a point on the graph. Wow. Okay. Vertical asymptote tells me right away I need to be dividing by x minus the vertical asymptote. So I know we're going to have an x plus 2 here. So that for sure happens from this. Range of all real numbers. That'll make sense for this. Because this will hit like everything from positive infinity to negative infinity. Although it won't hit 0, right? How it is. So I don't know if that's actually, I don't know if that's possible. Okay. Decreasing for x is greater than negative 2. Okay, so if x is greater than negative 2, then this is a positive number that keeps getting bigger and bigger and bigger. So, yes, okay, so that would keep happening. So that's a positive number that keeps getting smaller. Okay, so that's okay. Okay, y-intercept at 0, minus 1/2. Interesting. So that means I actually need to put a minus sign on this, which might actually screw this up. Oh, interesting. Here's another thing here, though. They said, has a domain of x is greater than negative 2. Oh, okay. This tells me this is not what I want. That tells me I need a square root. I'm going to say this is the square root of x plus 2. Okay. And actually, this works, right? Because this creates a vertical asymptote as you get really close to negative 2. Right? Kind of? Or, okay, maybe we need 1 over that, actually. Actually, I'm starting to think it's this. Sorry. No, I think it's this. Sorry. Square roots don't have vertical asymptotes. They just stop. Right? The square root of x looks like this. That just stops at 0. So square root of x plus 2 would just look like this. It would just stop. So if I want the vertical asymptote, I need it on the bottom, actually, because I need to divide. Okay, interesting. Okay, now... Okay, so that satisfies this. It satisfies this. And then it will satisfy this as well. Well, no, because now y can't be all real numbers. Oh, man. Yeah, it has a vertical tangent line, though. Yeah. I think this is where it would maybe help to know, like, what family of functions they're trying to get to, anyways. Yeah. I think there has to be an X on this, too, actually. I think there has to be an X here as well. Because this will enforce that I can get to all values of y, right? And then the x equals, but that won't help with this. So I think I need like a minus 1/2 here, right, for this to work out. And then is it decreasing for all x is greater than -2? It is, right? Because as long as this is getting bigger. Well, but then this is -2 as well. Yeah, let's try graphing. This is kind of a mess. Okay, I'm gonna say 1 over square root of x plus 2. So, cool. The issue here is this doesn't hit all values of y. So this is where I feel like I need to put an x in there. Now it does, right? But now I need it to be decreasing, so I think I need a minus sign in there. And then I need to enforce that 0, -1/2 works, so I have to minus 1/2. You're thinking ln? Ln could work as well. Let's see, I think this is good so far. Wait a minute. So this is decreasing for greater than -2. It does hit all the y values. It does have 0 -1/2. So this is what we have so far. I have a minus sign on this. And then here, it has the point 2, -1 on its graph. So if this is 2, so if I have -2 over the square root of 1 minus 1/2. Or no, sorry. -2 over the square root of 4, which is over 2, minus 1/2. Damn, that's 1 minus 1/2. Bro, got any advice on balancing a lot of studies? Write down what all the due dates for everything is, and then prioritize which one you need to work on. Like, which one's the most dire. I guess there's also like a cost-benefit analysis as well. Has an x-intercept of -1, 0. It doesn't work either. Fuck. Breskel says, low-key, I think most of the questions here are being spammed by the same person. Interesting. Well, they must be using...
Yeah, well, because I'm watching either it's someone else, like, they're having, like, other people submit them, but
That's
I'm
cute.
watching the upvotes, and it's the same ones selectively all getting upvoted at the exact same time after 3 minutes is over, and they just keep coming in, and none of them seem to have any, like, correlation to anything that, like, we've
maybe
done
we're just that
before,
popular.
just, like, random
But maybe we're
names.
just that popular, though.
Nice.
I don't know. We got, like, I think it was, like, 20 viewers on Twitch, and we got 15 in queue.
Yeah. Micro breaks, yeah, those are good too. Negative ln of x plus 2. Okay, that's another one to do. We could try that. Let's try that. Also same properties. Kind of looks the same, right? Here's the issue though. The issue is that, like, wait, how am I gonna get the point, like, 2 -1, right? I am streaming on Kick, actually. Oh, that is cool. Oh, do you think people found us on Kick? I don't think so. We have 0 viewers on Kick, so I don't think anyone found us on Kick. Oh, wait. One person did follow us 20 minutes ago. Thomas Washington. Thank you, dude. You need to make it so that a good problem can be simultaneously upvoted by multiple viewers. Yeah, that gets dangerous, though. Because then people will just create a bunch of, like, quote-unquote accounts, and then they'll flood all the votes on one question. That's the issue. Yeah. We'll figure it out. I don't know how to do this. Okay. Well, when this happens, I'm just gonna send it at chat. Just in the issue of time. It's kind of hard getting all these conditions at once to line up. Someone had a good idea of you can make a table of transformations, maybe. Yeah, you can do that too. I gotta like stretch it and stuff, you know? That's the issue. Because I don't want to like affect some of the intercepts and things. Yes. Zev invited me to the stream. He said you guys help with AP level questions. We do, Sancho. Alright, here you go. Okay.
I just watched 11 questions go from timer to upvote all within about 6 seconds.
That's funny. Well, at least someone's manually clicking them. Otherwise, there's no real way to tell which problems are more desired overall. Yes, I agree. Okay, here. This, I think, technically is the one that works. I guess it makes sense, right? Because log base 2 of 1 would be 0. Cool. How do you get the 0 minus 1/2? Oh, okay, because log base 2. Dude, this is so tricky. Look at this. You need to define it as log base 2 as well, because you need this to hit. Jeez, that is tricky. Okay. Yeah, what's up, Pen? All right, here, I'm gonna mark this one done, but I don't know exactly how to do that off the top of your head. That's kind of messy, man. It's a lot of guess and check, I guess. What's up, Pen? What's tunic time, by the way, Pen? You want to tell me what, like, tunic time is? Oh, damn it, I hit the wrong thing. Sorry. I marked breasticles already done. Okay, breasticles, you have to go then next, yeah. I'm sorry. Fuck, I gotta be careful about that. When people skip the line,
Works for me.
I need to put something so it manually puts them. That's the issue. So many things to figure out. Okay, one sec. Lucky Cat was number 6. Okay, there we go. Let me post 6. I'm gonna delete 6. Okay, and then there we go. That's correct. Okay. Add 1 to pineapple. And then gladiator bottom me first. I'll do gladiators, and then I'll do breasticles, and then the rest of you people who submitted a gazillion questions to the queue are at the mercy of the spinner wheel. And then I have to go and think about new ways to make this thing like impermeable. It's fun though. I love it. I love geodesics on a cone. Who's submitting these? Dude,
yeah. Look at the votes now. They just.
No, I see it. No. I'm gonna give them credit though. I'll give credit to whoever's doing this. They are fun. But I would just go through and be like, I don't know how to do these. Have them submit their attempt at solving it alongside the question. It could be a thing. Okay, gladiators. Is yours a differential equation? That's yours.
Yeah, I think that one says.
Is that the Golden Gate Bridge? They are, these headphones are Audio Technicas. I guess it kind of does look like a bridge, per se. But yes, sorry, for Zev's friend, what AP level classes do you need help with? Is it like AP Calc, AP Physics? Zev's another awesome person, really good friend of mine. He's the other admin in our Discord, in the case that I'm not able to continue my admin duties at any point in my life. Okay. Arya said they already solved this. That's cool. let's maybe like I just maybe want to try it myself, just to like see. For what values of m does y equal a e to the mt satisfy this equation? Okay. Okay, so dy dx is going to equal to dy dt times dt dx, right? But t doesn't function as a function of x though, right? Wait, did you do this correctly, Arya?
I
see.
T is just a typo.
Oh, you think that's a typo? Oh, you think that should be y equals ae to the mx?
Yeah, I feel like that's a typo.
Okay.
Because y e to the or y equals a e to the mx would be the the general form, right, for your eigenfunctions.
Right. Yeah.
Eigenvalues.
Yeah, this one makes sense. Okay.
Equation,
So derivative of e to the x is e to the x times whatever's on the top here. So this becomes a m e to the mx or amx. And then the second derivative, you bring down another m, so then that's am squared e to the mx. And then here's the cool thing: when you plug this in, right, for all of the things, that becomes am squared e to the mx plus am e to the mx minus 6a e to the mx equals 0. Yeah, and this is a very fundamental, basic trick for solving homogeneous differential equations. Is because look how you have e to the mx in every single term. You can just get rid of those. So they're gonna go away. So there you go. There you go. There you go. And so now you just have am squared plus am minus 6a is equal to 0. Oh, we can also get rid of the a's.
Emotional.
Oh, yeah, get rid of the a's. What am I even doing here? Okay. Okay, there you go. Okay. This is a quadratic you can solve. So this just becomes what multiplies to -6 but adds up to -1. And so that's going to be -3 and 2. So I'm going to say m minus 3. M plus 2 is equal to 0. So m equals plus 3 or -2. And your solutions are y is equal to a e to the 3x plus a e to the minus 2x. So I'm just going to substitute m in for here. And then technically the solution is a blend of the two. It's a blend of this one and this one. So you have to say like C1 times that. And then this is C2 times this. Where this is the percentage of like which one shows up more, I guess. And you can only get that from like initial conditions, which we don't have. So I think that's it. The beginning part. So you mean this part? Is this the part you want, Gladiator? Yeah, okay, cool. So they already said assume that the solution looks like this. Yeah, so m can be both. Yeah. Yeah. There's two different values for m.
Yeah, so not to get in the weeds, but technically what your values of m are your eigenvalues of d, right? Where d is your derivative operator.
Uh-huh.
So technically what you're finding using the characteristic equation are the eigenfunctions, the eigenvalues of the polynomial in D, and then the e to the mx is the eigenfunction of D.
Yes. Yes, if C1 is equal to 0, it'll be entirely m equals -2, and if C2 is equal to 0, it'll be entirely m equals 3. But yeah, when you get into higher level linear algebra stuff, which again, Gladiator, you don't need to do that yet. These do refer to like eigenvalues, eigenstates, eigenfunctions. It's all fun, fancy stuff. But okay, so Gladiator. What happens anytime you have like different orders of a derivative showing up in an equation and it's equal to 0? A common solution for this is to say that your solution is y is equal to a e to the mx. This works a lot of times. So they already gave that to you. Usually you would guess that. From here, I want to calculate the different derivatives. So the first derivative of this, right, is the same thing as the derivative of e to the mx, but the derivative of e to the mx is e to the mx times m. So if we remember right from chain rule, so d dx of e to the x is just equal to e to the x. But d dx of, let's say, like e to the 3x, that's equal to e to the 3x times 3, right? It's the original thing times the derivative on what was on top. Yeah. Yeah, this is definitely t versus x fail. This should have been x. So the first derivative, right, will pull down an m from the chain rule. When you take the next derivative, again, you get another e to the mx, but you also pull down another m. And so that's why this is m squared. You can think about like taking the second derivative is like ignoring all this, taking the derivative of this, but that's going to pull down an e to the mx and then like another m, which multiplies by that m to give you m squared. So then this is the 0th derivative of y. This is the first derivative of y. This is the second derivative of y. And then those you just plug back into here, Gladiator. Right? Plug in the second derivative one for the second, first for the first, the not derivative, the 0th derivative for the other one. And then you just start canceling things. You'll notice that they all have an a in front of them, right? They all have an e to the mx attached to the end of them. And so then it simplifies to this. And this is like a nice polynomial that you can solve. You guys recognize the Griffiths? Oh, that's fun.
Good job.
Does that make sense, Gladiator? Again, always ask questions like if any of these parts like don't make sense. I'm always happy to explain. Oh, I see. My teacher never went over this. Oh. Well, not yet, I guess. Okay, cool. Well, yeah, it's like intro differential equations, but good question. It was on last year's test. Well, I mean, okay. Your teacher may not have gotten through all the material they wanted to this year that they did last year. I don't know, like, shit happens. Teachers get hungover, or like, I don't know, there's a holiday, or I don't know, the war in Ukraine or something. There's always something happening. So just because it was on last year's test, if you have never gone over it, it probably won't be on this year's test. Okay. But it's cool. I mean, that's definitely cool to see. They don't get paid enough to give a shit. I don't know. I have debates on that because some teachers do get paid a lot. And they still don't give a shit.
Oh, no.
I think there was a very interesting, what was it? There was a study that I saw that talked about how the second like technology is adopted by the classroom, like grades just like go way down. So I think it's a combination. Like technology is supposed to like help us teach better, but then sometimes it gets used as a crutch to, I guess, make teaching more efficient, but then teaching isn't better. And then sometimes like teaching has to become more efficient because you have too many people in your classroom and not enough teachers. It just becomes this cat and mouse game of technology comes around and it's like, yay, okay, now I can teach more effectively. So then whatever, the school district is like, okay, so now we can just hire less teachers. And then the teachers have to use the technology just to like stay afloat. I hear so many students I work with that talk about, oh yeah, my teacher just like gives us YouTube videos to watch and then we just ask questions during class. And I'm so confused. I say, wait, but you're not learning from your teacher anymore. You're just learning from a YouTube video, which you're not going to do on your own. I know you guys.
Oh, no.
You ain't going to like watch shit and like learn from it. But maybe the teacher is just so overwhelmed with like now grading for 40 students when they used to grade only for 20, that this is how they like protect their energy and their peace, is they say, okay, well, I'm just going to offload the teaching part to whatever technology platform we're paying for so that I can have time to do the grading parts. And then even that's getting replaced because now AI starts auto-grading homework and stuff. I even saw it when I taught at UCLA. You used to get 2 TAs for a 180 student class. The year I taught it, they dropped it to 1 because they just can't pay TAs anymore. They can, but like they don't want to. So if you only have 1 TA to now help grade 180 exams, what do you think happens? You start looking for, okay, is there a way I can use AI to just speed up the grading? Or at least handle the grading. So it's all fucked. Yeah. Yes.
Or they could just assign less homework.
Sure. I mean, that's just another, at the end of the day, there's so many things at play. I understand why the whole like field of education is fucked. Because now you have kids that are speed running diplomas. They're speed running their grades. It's like those annoying HR trainings you get whenever you join a company. It's like learn about sexual harassment or something.
Oh no.
You're like, dude, not again.
In fact, most jobs when you do that, you can just actually skip the video.
Exactly. Well, okay, so the problem is that like now with AI, students can do that with homework. They can do that with any of the other things. So this is why I guess teachers are like, shit, like, well, what do we do? Just assign more homework, I guess? Like, I don't know.
Well, like, so like what happened with me in like my physics class, we didn't even have like homework that was due or like graded, right?
Yeah.
So it was like, my teacher was like, yeah, I don't really care, just like perform at the level that you're capable, like I'm gonna grade based
And like,
on
yeah, I mean, you
exam.
should
And
learn
he
on
would
your own
just
that you need to do homework to
give
do well
us-
in the class, but people don't realize that.
Well, he would give us like daily assessments, right? So like it would be like a 1 question, wasn't worth a lot, right? It was just like a homework assignment, quote unquote. But he was like, I don't care like how you learn it. I don't care if you do the homework, whatever. Y'all got other shit going on outside of this. So just like, you know,
Yeah.
learn it, do what you need to do, and then
Get it done.
if you perform on the test, perform on the test. That's all I really care about. And it made grading way easier for him. You know, he could do it, and he would just do like self-grading. You would just like
So
grade
I do
based
this
off
as
what
well.
you think you got.
Yeah,
and
I
you
do
just verify if you.
I do this in my classes, and I will do it this summer as well, because again, I will have like 140, 150 students, and even more so, it's 3 exams in 6 weeks. So there's really no time at all. What I do is, and because it's a completely online class, I have an online platform. People will take their test. It's kind of bolstered against using AI. Again, you can kind of use AI just to get it, but I make students submit their work. And then if they get the answer wrong on typing it in, they automatically get half credit for everything. So this is like a way I make my grading easy, is that if you get it right, you get 100% great, and I'll go through and make sure that the work you wrote doesn't look like total AI slop and like looks like you actually attempted it. And then cool, I'll give you the grade. I don't care. It's not my job to be police. But if you get a question wrong, rather than me manually go through and like try to figure out how much partial credit you should have, I automatically default to you get 50%. And then I tell students that if they want more, they need to go through their exams and they need to write me up like a correction type thing of, hey, this is what I did wrong, this is what I should have done, and then I'll give them back, I don't know, like half the points they should have got back or something. And so now I'm not spending the time I don't have to give partial credit to 170 exams. I put the burden on the students, and it's not really the burden, it's the learning experience on the students, because the students now have to go through their own stuff. They have to figure out that what they did wrong, and now they know to not make that mistake again. And then so many less of them will submit requests for extra points versus me going through everybody trying to figure out who gets extra points. So
yeah, that's a lot like how it was on in my course. It was based off of like a scale of 10, so you would turn something in, and it was kind of based off of like how the AP exams were. So you'd get like a 5 if you just wrote some shit down on the paper. It could have been like electricity and
you
magnetism.
could draw me fucking SpongeBob. Dude.
You could have thrown anything in there. You get guaranteed a 5 if you at least like wrote the right point of initiation you get like a 6.5. What's the next one up? And then if you were like pretty close, like you had the right idea but you didn't quite get to the answer somewhere, you messed up your work, you get an 8.5. And then if you did it like perfectly, you'd get a 10.
Yeah, that sounds good.
And
Green Eyes.
You just go over it right after.
One sec. Green Eyes. You said I'm 42. My instructor doesn't teach. Surprise. That's what we're talking about. Final coming up. I need help with shell and washer methods. So I'm gonna send you some videos. I would help you, but I don't have time right now. If you want to come by the stream on Thursday, I will have time. But I have a really good video on how to do volumes of revolution, because that's what you're dealing with, I guess, right? Is the shell and washer method. So click. I'm gonna give you this link. I go through all the cases of how to solve different volumes of revolution. I do everything with washers. Shells suck. If you have to do shells, you can come by one of my streams and I'll manually help you with it. But everything else you can really just do with the washer method. It's pretty much supreme. Where's my YouTube chat though? One sec. Fuck, where did you go? Oh, there it is. One sec. One sec. So here you go, Green Eyes. There's a video. If you click on that video, there's a part 1, 2, 3, 4. So this is like simple volumes of revolution. It should say like what's the next related video. Maybe at the end here it does. The hell. Okay. The other way to do it is if you go to our channel here, Actual Education, just type in volume under the search bar here, and then you'll see 1 of 4, 2 of 4, 4 of 4, and there's 3 of 4. So these are all the different ways to do volumes of revolution. I go over like the vertical case, the horizontal case, what you do when you have to find the area in between things, what happens when the axis is off. Like, just go through those videos. They're great. And if they still don't make sense to you, again, come by our other streams. I'm going to do one last question today, and then I got to go. But the website, actualofficehours.com, if you click here on the streaming schedule, you can see the calendar of all the times that we stream. And so we'll be on again on Thursday. You can go check that out. And then otherwise, yeah, we got the people's hack. All right, here, let me do Breasticle's question. We're going to learn about hyperbolic tangent.
Yeah, somewhat.
Something like that. Something like that. All right,
yeah, someone definitely just botted it. There's like 6 or 7 or 8 different pages.
You know what I'm gonna do? Like... So anybody who submits questions, I grab their IP address. I'm gonna go check the IPs.
Yeah, like
I'm gonna go find out who you are.
Like,
I'm gonna go find out who you are.
There's like probably 7 or 8 pages of necessity or something of some book.
Dude, what
all
is this?
All those bottom ones. Look at the very bottom ones.
I can't even get to them. The code is not made for this many questions in the queue.
It like kind of gives you a click if you go to the far left.
Oh, dude,
it's
what?
It's all just a bunch of pages of this.
What? Someone just putting in pages of a book? God damn it, guys. Why? Why would you do this? Why?
Oh, and then there's an M&M person somewhere, like one of the M&M characters, the red one.
Okay. All right. Whatever. All right. Stress testing. I like the stress tests. They're good. I got to figure out something else because someone's getting past the IP ban. They have, I guess, VPNs that they want to do. Which, yeah, all power to you, man. If you want to keep like flooding it with IPs, yeah. Okay. Cool. With VPNs, whatever. All right. Let's see. Let u of x and t, be a scalar field in the 1 + 1. Yeah, you can't click them. Yeah, I know. Here, I can just start deleting them. One sec. There you go. It's funny because they all have like 0.4 of a percent chance, which actually, I think is, oh, it's just because it's diluting it so much. 13 and 14. Okay, one sec. There you go. That should be at least more. Yeah, now you can now at least view it, right? Okay, there you go. Okay, it's still there. All right, let's do this one. Okay, 1 plus 1 dimension satisfying the first order quasi-linear PDE. Oh, Jesus. Okay, here we go. U of t plus c tanh of u ux equals 0 with the initial condition that arc sinh of x is that, where c, assume u plays a role in the rapidity field so that the associated physical velocity field is tanh. Okay. Okay. Fine. Solve the PDE by method of characteristics. Okay, let's see if we can do one part of these.
Yep. Characteristics shouldn't be that hard.
Okay. All right. This is the PDE I'm trying to solve.
Yes.
Okay. Cool. Fanbox says this looks awesome.
It's like a relatively
Okay.
question.
Okay, so UT, so whatever. So that's du dt, right? Plus c tanh of u, and then I'm going to say du dx.
Yep.
Is equal to 0. Okay. This almost looks like a wave equation thing because I got du dt and du dx. Yeah.
It's more like it's more of a nonlinear transport equation. This is very reminiscent of the shockwave equation, which is usually ut plus ux.
Okay.
So what we're gonna do here is called the method of characteristics. That's why it says solve it by method of
it does say the method of characteristics.
So if you remember from Calc 3, the exact derivatives.
Yeah, sure.
Right. So
what, like ddx is equal to like partial, I don't know, whatever, plus partial or something.
Yeah, in essence. So you'd say that du ds is equal to ut times dt ds plus ux.
Yeah.
And then dx ds.
dx ds. Okay. Yeah, this is called the total derivative. Okay, got it. You do a partial and then you do another total. Okay.
And then we can basically just like kind of look here and match up our equations or our derivatives.
Oh, right? I see. So
if we look at
this is right here, right? This is right here. So that tells me that dtds is equal to 1, right?
Yep.
Cool. And then dx ds is equal to c tanh u.
Yep. And then
cool.
We also know that du ds
and then du ds is equal to 0.
Yes.
Beautiful. Oh, this is cool, actually. Okay, fine. Du ds is equal to 0. Okay, great.
And that basically tells us that
t equals
along
s.
these characteristic curves, that it's constant.
Okay.
So now we're gonna let the initial point at t0 be labeled by c or chi, right? The xi, the squiggly.
This one.
So we'll say that the lowercase like squiggly looking thing looks like a
this thing?
epsilon, but
this thing.
Yeah, it looks
like
like
this.
epsilon, but like you have like a little curve on
epsilon
the top,
had like a stroke.
On the bottom. Yeah.
No, God!
Okay. I hate drawing this thing.
Next time.
Can we use something else? I really don't want to draw it. I fucking hate it. Can we use like eta?
I guess
eta
like
or something?
Epsilon.
Let's do epsilon. I like epsilon.
Because the problem is that like that one you specifically use like in method of characteristics. Like it's one of some of those Greek letters that when you get into
They couldn't pick a
PDEs,
better
like,
one?
I guess not, but it's like the SI units in physics. It's kind of one of those things that it's just like everyone in the field agrees to use. But yeah, you'll say that u of epsilon comma 0 is equal to the arcsinch of epsilon.
Okay, u of epsilon, comma 0. I see from here, right? Is equal to the arcsinch of epsilon. I agree. Okay, cool. That came from
And
this,
then
yeah.
what we can, and then what we can say is since u is constant along our characteristic lines, that u of xt is equal to the arcsinch of epsilon.
Okay, one second. Okay, u of xt.
No,
wait,
like
wait.
x comma t.
Okay, u of x comma t is also equal to the arcsinch of epsilon.
Yeah, because basically the idea of the method of characteristics is to, in essence, reduce it to an ordinary differential equation by looking at what's called the characteristic lines, and we can take a look at it and basically say that our solution to our PDE is going to be constant along that characteristic line. Right. So along those lines, it reduces from a PDE to an ODE.
Okay.
And so we can get those.
Okay.
Yep.
So,
And then,
do I want to solve these things?
yeah, so we'll want to solve for what dx dt is, which would be c tangent u.
Dx
And we
dt.
just get that.
So wait,
Yeah,
is
we just
that
get
is
that
that
by
partial
saying
x,
C
partial
is
t?
equal to S. No, just straight dx dt.
Dx dt.
Because S can be anything.
Oh, I see.
Generally,
okay.
we generally like to say, right, choose whichever variable is that constant. So in this case, right, we have 1 as a constant, so we can say.
Okay. So,
Let's go
I see.
dt.
And then for this, right, dt is gonna be equal to 1. Is that the intuition for it?
Yeah, that's kind of the idea.
Oh, okay. Well, okay. So yeah, my first step would have been from this, right? From this, I would just say, oh wow, t is equal to like s plus c, right? If I were to integrate this. And so so
S
dt
is kind of like
equal
a
to
dummy
d,
variable.
right? But dt is then equal to
case.
ds then, right? So I could replace this. I get that you could just pick it as whatever. I just think that it's kind of cool that also like lines up.
Yeah.
So
or even if you substituted s for t and your t equals s plus c, it just subtracts the t and you just get c.
Okay. So dx dt is equal to c tangent u. Okay. But du dt is equal to 0 from here, right?
Yeah. Well, so what we can do here is, since we know that u of xt is our arcsinch of epsilon, you can plug that in for your u.
Oh, I
this
see.
Case.
Okay, cool. And then tangent of arcsinch. Oh no. Oh no,
Oh,
dude.
we can just leave it in that form for now.
Oh, we're just gonna leave it? Oh, I thought we were gonna like draw more triangles.
Yeah, we're not just yet, no.
Okay. So this is arcsinch of epsilon. Is dx dt. Okay, cool.
And then we're gonna do some simplification. So we're gonna introduce a variable theta, and we're gonna say let theta be equal to the arcsinch of epsilon.
Theta. Okay, cool.
Yep. And then so we got sinh of theta is equal to epsilon.
Okay, I agree.
All right, and then using basically like the equivalent of our unit circle for hyperbolic trig, cosh squared minus sinh squared equals 1, and that comes from our unit hyperbola, which is like the analogous.
Nice, Arya Cuddle. Yeah, enjoy the Matic stuff. I'm glad it's incentivizing. What's this, like unit parabola, dude? Unit parabola?
Yeah, it uses a unit parabola instead of the unit
Learning
circle.
so many new things today. Okay, so this is
first
it.
one describes it best.
This is it.
Yeah. Mhm.
Okay, so this is like the equivalent of the unit circle, but this is in like hyperbolic land.
Hyperbolic,
Oh, I get.
yeah.
It's a hyperbola. Yeah. Okay.
Oh no.
Oh my god.
Yeah.
I
Yeah. You
understand
literally
now.
just.
It's literally
You're
called
like, yeah,
hyperbolic
so-
trig. Oh, okay.
Yeah.
Okay, fine. Okay, so cosh squared minus sinh squared is equal to 1.
Mhm.
Fascinating. I don't know where that comes from here, but okay, sure. Oh, yeah, wait.
It kind of shows it on the left a bit.
Yeah, I see, because it's x squared minus y squared equals 1. Got you. Oh, okay. So, okay, I think I get this. Okay. All right, so from that, do I want to do something here with epsilon or something?
So what we're gonna do is we're gonna solve for cosh actually.
Okay, so cosh is equal to the square root of 1 plus sinh squared.
Yeah, but we know that sinh is equal to epsilon, so we can say 1 plus epsilon squared.
Okay, so cosh of theta is equal to the square root of 1 plus epsilon squared, and that came from this.
Mm-hmm. Yep, and then so we can take a look at our tanh arcsinh that looks really ugly, right?
Mhm.
Our tanh is going to be sinh over cosh.
From here, right? Yeah. Okay, so tanh
Yeah, it's like basically all the same identities.
sinh over cosh. Oh, okay, and sinh is epsilon, and cosh is square root of 1 plus epsilon squared.
Yep, and then so we can say that our characteristic ODE becomes C times that.
Okay,
Right,
so tanh.
so our
Got you.
DXDT.
This is cool. Tanh of theta is sinh of theta over cosh of theta. Sinh is that, cosh is that. So dx. Nice area. dx dt is equal to C C times
That,
epsilon over
epsilon, yeah.
square root of 1 plus epsilon squared. Okay, cool.
Mm-hmm. And then we can just integrate at x equals epsilon and t equals 0. Or using x equals epsilon and t equals 0.
Sorry. X equals epsilon.
Yes.
Why does X equal
You should
epsilon?
get
Oh, because we did do that here.
that's after. Yeah, that's after. I think that's after.
Okay, wait, so I'm just going to
I
move
figured
this
this
over.
out like 10 minutes before stream by talking with chat, so I'm kind of
Okay.
going off what it
All right, so this is what I'm
recommends
going
me
to do.
a bit here.
So wait, sorry. I have this, right? And then I'm going to move to
Just
each side,
integrate,
right?
yeah. Mhm.
Okay. So, and then, okay, so this is just going to become epsilon. And then, is this all times just t?
Yeah. And then you're gonna have a technically, so we'll leave the epsilon that you wrote first as x, but you'll have another function of x, and that function of x is just going to become epsilon.
Okay.
Because we integrated partially, technically. They were ordinary derivatives, but it is still a PDE, so there are functions.
Okay. So I'm going to say x of epsilon, I guess. I don't know.
We just want to say s or x.
X.
It's not really a function in this case, yeah.
Okay. X is equal to ct. It was equal to all this, yeah?
Yeah. And then plus an epsilon.
Plus another epsilon? Why is there another epsilon?
Yeah, I think so. I believe it comes from the fact that we're integrating in a PDE to get a derivative.
Okay.
I'd have to look at chat. I didn't have time to like fully solve this.
You're good.
Very fat nap today after my class.
I know. I do. I
But
desperately
then
needed a nap today.
Yeah, I was gonna do it. I was gonna like actually
gonna
like
nap.
figure out and solve the problem.
Yeah.
And then I fell asleep. And I was like,
The sleep calls.
I'll just ask. Yeah, I woke up and I was like, whatever. I'm just gonna ask ChatGPT for a problem and a solution set and look through it.
Okay.
But then from here we get our implicit solution. Normally we would want to try to like get epsilon in terms of like x, y, or x, y, t, z, whatever values we have. But that's not really possible or easy or worth any time or effort that we're going to put into it. So we can just say that our u of xt becomes equal to the arcsinch of epsilon, and then our x is equal to that.
And then x is equal to this? Oh.
Yeah.
Cool. Are we done?
Yeah. I mean, there's
Nice.
like all the other stuff, but
We'll do the other parts another time. Perfect timing there. Okay, this is cool. I really like this. This is really dope.
That's dope.
I didn't know about this unit hyperbola thing. That's really cool. Makes sense to me now.
Yeah, there's a lot of.
And then I'm glad that I
identities
remembered what a total derivative is. This type of stuff's kind of like,
Oh no.
I don't really know what's going on, but it's one of those things. If you just get a lot of exposure with it, eventually it like starts to make sense. Cool. Good question, Breasticles. What's the queue up to now? 22 questions. Who keeps submitting all this stuff, dude? What? Chill. All right, I do have to end the stream though. But just to make things fun, because I don't think we've ever had this many people on the wheel, I'm gonna spin the wheel. I just want to see what happens. We gotta stress test this, right? We gotta stress test this.
It's just more of the book.
Is it?
Like,
all right, let's see.
Yeah, it's all just of liberty and necessity.
What is someone trying to say to me? Okay, so here's the queue. I can't even read the queue. But let's see what happens if we try to like choose a winner. I'm curious.
Let's go get
Oh, dude, look at all the colors there. Look at all the colors. But it skips over all of them. So it would have been gingerbread. It would have been you, gingerbread. I can't even like click on their question though. Jesus. Oh, there we go. And this was something with like beats. This would have been pretty cool actually, doing beats. I think I could have done this. Yeah. Because this is the sum to product rule with sines and cosines. This is very cool. I would have really liked to do this question. It is really fun. Yeah, beats and envelopes. Yeah. Still greedily waiting for Breasticles to stream. Yes, we are too.
I will get to that once I get moved in. I'm trying to decide if I should get like a camera on my deck, because from my deck by my apartment you can like see the beach.
Oh, that would be dope. Yeah,
like
show us what like
a beach
touching grass and
camera.
like, touching water is.
Exactly.
Nice. Okay, cool. All right, let's close that stream. I gotta go. All right, thank you everyone for coming to Actual Education Office Hours. Appreciate all the questions. Appreciate all the book you submitted or whoever that was.
Oh no.
Thank you for stress testing my system. I gotta figure out some way to stop that, but great. I love the challenges. Anyways, our next stream, again, if you were watching us on any of the other platforms, go to the website, actualofficehours.com. You can click on the streaming schedule here, and this will show you all the different times we're streaming. So Zach has a stream tomorrow morning. He's going to do Diffie Q. Penn Center will be doing some more math help, and then also Tunic Time. I don't know what Tunic Time is, but it sounds fun. We will be back Thursday to help you guys out with math and science. And then Friday, we'll be doing recess games. I'll see if Naroski wants to stream with us on Friday. Euclid math contest. Okay, cool. I guess that's a little bit different. Is that what Tunic Time is? It's called the Euclid math contest, I guess. That's cool. All right, so let's go raid someone. Let's see who else is on our sphere of friendship. Yes, good to see you, Justin. Thanks, everyone, for coming by. Super fun. Let me see. I got so many people that are streaming these days. I keep meeting more and more friends at all these Twitch events, and then I add them. Let's see. Oh, those are my friends that are DJing. Those people are cool. We haven't said hi to Science in a while. Let's go say hi to Science. I haven't. Oh, and also, yeah, it's his wife. She's fun too. Go say hi to Science. They're cool. Other big math science streamers. We love them. Okay. Enjoy the rest of your Tuesday, and we'll see you on Thursday. Peace.
I know it's a 5-foot flower. That's technically against HOA. Welcome the heck on in. Let me pull up the raid real quick here, y'all.
Science stream, but we ain't bugging. We over here buffalo. You be shocking what we got. Now the tracks arrive. I promise that I have prescribed you vibes. The vibes we got are giant. Shout out to the stream for the raid. That's science.
Welcome the heck on in. How was your stream? What were you up to? Tell me all of the things. I hope you're having a fantastic Tuesday.